Hello guys, welcome once more to the Main Squad YouTube channel, and it's glad having you guys back. So it's been quite a long time right now. I've been present, so we'll just continue from where we stopped because in the previous chapter we were treating enumerations. So you know what I'm saying, all that. So today we'll be progressing to actually a new chapter in which we will be dealing with generics, and generics is something really important and really nice because it allows you to write flexible and reusable code. We are going to see that in a couple of in a while now, not far from now. So instead of writing the same code over and over for different data types, right, why not just be able to write it once and use it? And that's where the power of generic comes in. So let me just take you just simple analogy. So imagine, for example, we have a box, right, that can hold one item or many. But now we'll also have to make in such a way that, let's take for example a case scenario where the box could hold, we could make it hold only apples, right? So that means the box will not fit when we need to use it for oranges. So that means we need to make again another box for oranges. But if we can make the box in such a way that it can, the box the box is like generic, like we make it generic 8, right, such that it will work with anything we put inside of it. So that's just what we mean by generic, like being able to hold um different data types, right, being able to work with different data types, not being constrained just to a particular type. So we're going to start. So as we usually do, you can see I've already zoomed in, and as usual we're going to create our folder. Well, let's just name it generics, and we're going to create our first example, example one of that, as we always do. And let's open this in our terminal for easy access. And okay, let me just bring this down a bit. So we're going to start with the first type, which the first function in which we're going to use generic with a function, such that that function is just going to be able to return to us the type that we passed with, like the data type. If we pass in a variable, it's going to be able to tell us what is its data type, and that's just it. So it's very simple, pretty basic. So as usual, let me just remove for now the terminal. We're going to go string, and we're just going to call it identity. Okay, now how do generics come into play? Generics come into play whereby we use this open and close, should I call them brackets? Yeah, if I can call them that. And we use a t just signifies the data type. That's just what we use. So it's just a data type, and we say t, for example, value. Okay, and now you're going to be able to see that the main goal of this function is to be able to return a data type based on the value we provide to it, right? So means we're going to switch. Let's just switch on that. We're going to switch on the data type, okay, and then be able from here to provide different values. So for example, case int, okay, we're going to return, we're going to say this value, okay. What just happened? Okay, we're going to say $ value is an int, okay. And we are going to continue doing this. So let me just copy so that we don't get to waste much time here, and do this as well. So you see, in this case scenario, we have handled all the possible cases. Can I be able to refactor this code? Yeah, Control Shift I. Okay, so you can be able to see that with this now we can, if it's the case is an int, then we are going to return an int. If it is a double, then we will be able to return double string value list map and so on. If it's a type we're not switching on, then we're going to throw an argument error, which creates an error with the message. We're going to dive into that with exceptions in the next chapter. So if we now go to our main, let's create a main function. okay, and in our main function we are just going to print, okay, let me just bring this in. Let's print identity, and let's pass in, for example, 4. Okay, we're just going to pass in some couple of them. So here we're going to say 12.4. okay, here we're just going to say hello dart. Okay, here we're going to say we're just going to create a list. Okay, 1, 2, or 3, anything, and here we're just going to pass out a map. Okay, so let's now go to our terminal and bring this up a bit, as well as this. Let me clear and say that let's example 1.dart. Okay, so okay, we fell into some exceptions here, but it's not an issue. We can be able to handle that. I think it's because I just provided this here. Shall I do this instead? Okay, I think the issue was with the list. Okay, so as we can see now, 4 here obviously is an int or an integer. 12.4 is a double. Hello, that is a string. This is a list, and obviously the curly braces represents a map. So that's what we have been able to do. That's what generics makes gives us the power to be able to do, to be able to switch on different t, because this t actually represents the data type. Okay, it actually represents the data type. If you see here, for example, t, and it says here type, so the function function int, because we are passing in an integer. If I do same here, okay, if I do same here, you see double and so on, list dynamic, and so on and so forth. Okay, so that's the power. That's the first basic example that we're going to do. Now, still here in this example 1, I'm going to just add a simple function to be able to add. Okay, say we wanted a function which is able to add 2 numbers, right? int and int, or double and double. But now it should be able to return, when it adds, it should be able to return to us a double, or whatever number we pass to it, it should be able to return to us that data type. Right, so obviously you say, okay, then what's the common ancestor between int and double? Obviously num. So we'll just say add number. So we're just going to say add number, and maybe you will say num a, okay, and then num b, and then we just return a plus b. Okay, I'm just returning a plus b. Okay, right, so if we try printing this, let me do this. Okay, and separate that part from here. Okay, and for example just say add number. Okay, I don't know why this is refusing to work. It's kind of like stringful, but I guess I'll just find my way around then. Okay, so we're just gonna say print. We're just gonna say print at number 3 and 5. Okay, and let's maybe say for another one for doubles. Okay, so obviously this is going to return to us something, right? So if we say example that example 1, and we get 8 and 16.8, right? Obviously we will say behind the scenes it's an integer. For the first one it's an integer, and for the second part it's a double, right? But now if we try to look at the return type is actually a num, right? It's not an integer. Why? We want something that if we pass in an integer, it should return to us an integer. Like the return type should be an integer, and if we pass to it a double, okay, you could say, okay, why not just say int here, right? And you see that now we start getting some issues, because though we are specifying, we're using nums, the value of type num can't be returned from the function add because there's a return type of int. Okay, because these, both of them are using int, are using num, but we're trying to return an integer out of it. So how then do we apply generics to be able to make it generic? The same thing. We use t here, and we turn all of this num into t, okay, of type t and t, okay, and our addition this, we typecast all of this to as t. Now that is still not the end of it, because we are just saying t. So what is actually this t we are talking about? So we need to constrain this t to be able to only be used on nums, right? Because we want that if what we are passing in is an integer, it should return to us an integer. If we're passing in a double, then we should be able to return a double. So we constrain it by still putting after the function's name some open and close brackets, or less than, greater than sign, and then we say t extends on num. Okay, now with this t that's extending on num, you see the error, all the errors we're having have gone. So this t is obviously going to be, if we pass in an int, there is going to return to us an int. So if we go to our terminal and we still try to do that example 1.dart, we still get our same values, right? But now what has changed is that if we do this, okay, let's try to do this here. Okay, let's try to do this here and see what. Okay, so if we try to do this here, if we say for example hello, which is just a variable, and we hold this there and we come and say hello here, and let's close out the semicolon. So you see that if we hover over here, then we see that hello is of what? Of type int, which is actually what we wanted, right? We want that if we pass in an integer, it should be able to return to us an integer. Same thing if we do, for example, hello 2, okay, and we take this function here and we add it here and we put here hello 2, okay. These are just variable names, okay, nothing else. And we see here we have a double, which of course is actually what we wanted, right? We are passing in doubles, obviously the return type should be a double. So that's that with example 1. We are not going to go a little bit further with example 2.dart, okay. With example 2.dart, we are going to use generics and extensions. So we're going to see how we can mix them a little bit, okay. So we're going to have enums, extensions, and generics kind of like coupled together. So I'm just going to copy the class that I have, okay. So we're going to have here an enum class of colors, that's red, green, and blue. And we also have an enum class of days, Monday, Tuesday, Wednesday, up to Sunday, okay. So now what we're trying to do here is that we want an extension on which we can display an extension in which it will be constrained on the type enum, okay, enum of type t. We can use it on any enum of any type, right? And that enum is going to contain two functions, one in which it's able to display the name, and the other one in which it is able to parse it, that's like try to get a value out of it. But we're going to see that as we evolve with our example. So let's go ahead and write an extension, say extension keyword, okay. So we're going to call it enum helper. We've already seen how extensions work and how we name them, okay. So we're going to say t extends, okay, extends on enum, in which enum is our type. So this extends on t. So we have already seen how extensions work and what the on keyword does. So we're going to get on the string get, okay, display name. We're going to say display the name, and it's just going to be, well, that's just a quick getter, which we're just going to say this, no, this dot, I think it's to string, okay, and we split, we're going to split that on the pattern of the full stop, and then we take the last value. Well, we are going to see all of that, don't worry about it. I know for now it's all complex. So this here is just going to take the enum on which we are going to call it, and then it takes it to a string, we split it by the full stop, okay, and then we get the last value. And you can try replicating this example on your own, right? Trying to say, for example, if you enter this dot string, what it gives you if when you enter this dot split, but we are not going to get on that here. This is stuff you can try on your free time. Okay, so the next part, we're just going to have a static. This is just a static function which we're just going to say parse. Okay, the parse I was talking about, it as well extends on enum. Okay, and it accepts a string. Okay, so a string value and the list T on enum values. Okay, so and so here we're going to now return. We're not going to return the enum values dot first where, or should we just say first? I don't think I'll be needing this. I think I will be going with the enum value dot display. Let's just call it enum value dot display the name, okay, because it's not see, because of the extension it's available now on any enum, okay, any enum. So we're going to say enum value dot display name, and we're going to use first. I think that stuff is really first where or null. And mind you, this is not available in Dart, but it is available in the collection package available on pop.dev. So you can just visit pop.dev and search for collection to be able to find out more on that. Okay, with this done, we can say we can proceed then with what we have, and let's just write a main function. Okay, main function, and I'm just gonna copy the examples I have here so that we can go faster. Okay, so we're going to say example 1, and which is example 1, like we said, right, this display name is just to be able to get this colors dot red. Okay, we take it to a string, or we transform it to a string, we split it at this full stop, which we're going to have an array which contains colors, and then the other part is red, and then we take the last part of the array. Okay, that static analyzer is telling me I don't require this expression, so I can directly call it like this, and it's going to know that it's this dot to string. Okay, so if we try to show this on our console, let's clear that and say example 2, and do I get something? Okay, yeah, so we see we get red. We could as well try it with green. Okay, we could do, or even blue. I don't know about you guys, but blue is a nice color, so we could do that as well with blue, and then we see, but I made a mistake here. I was supposed to change this here to blue as well. That's why you're seeing red here, but that doesn't matter. So we continue. Now in the next part, in the next example, we're going to try to parse a string to get the corresponding enum value. So as usual, I'm just going to paste the examples I have so that we can go faster. And this is example 2. Okay, let me close this for now. So what is example 2 actually doing? So we have a string here called day string, and it contains the value of Wednesday. Now we have days here. Remember, we have an enum called days, which represents the days of the week. Okay, so when we come there, we have a day. Okay, it's optional, and then we have the enum helpers. The reason why it's optional is because the enum helpers.parse returns as well an optional value. Okay, so that's why we have days here optional as well. And we parse on days. Okay, we get this day string, which is this Wednesday, and as we earlier defined here, the list on T enum values. So list of the list of values. Remember, for example, in with enums, when we do this days dot values, we are actually getting the list. Okay, it returns to us the list. That's like something that's been implemented behind the hood. I didn't get to add this. So we say days dot values, which returns to us a list of days. And then with that, we can be able to pass the enum. So we are going to get this day string here, and if we get a day, okay, we're going to print it. Else, since it can be null, if we have nothing, then we just return not found. Okay, so a lot of explanation, but let's just go into action. Let's clear and put that. Maybe I should just change this here to blue since we're using blue. And let me just add a print statement here, dividing the section. Okay, and bring that down here. Okay, and I can redo it so that we don't get this. Okay, so we see now the parse enum value for Wednesday is days dot Wednesday. So this parser here is just to be able to get the values within that enum list. Okay, so we just get the display name. If the display name of this enum value is equals to this value that we're passing to it, then return to us that specific enum, which is days dot Wednesday. Okay, so we're just in the last case, we're just going to treat a case where we don't have whereby, for example, a day string doesn't exist in the, let me just call it example 3. Okay, I'm going to say string day string, and I'm just going to say holidays. Okay, holidays, remember holidays doesn't exist in a days enum, so the name day string is already defined. Okay, let me just use the string 2, and this is optional because the day string 2 can exist in an enum, among our enums, right, among the values of enums or not. So we are just going to say here enum helpers dot parse. Okay, we're going to say day string 2, and remember, to be able to get the list, we say days dot values, and you see here that is already smart enough to go ahead and tell us that this values is a list of days, right? So we get that there, and we can close that. There is already defined. Okay, let me just call this, it another day or invalid day. Okay, because we're not actually using, it doesn't actually exist, but can just go ahead and just say something like invalid day. And as well, I can say here invalid day string. Yeah, I think this will be more appropriate, so you can do that here. And I think with this we can go ahead and pass our enums, right? Because this pass is a T that extends on the type enum, so we can provide the enum that we want here to be days, just for type safety as well. And I think I'll just copy this here, paste it here, and say invalid day string, invalid day. And yeah, so let's try to print that out. Let's clear that console and let's run the example 2. And of course, here we see parsed enum value for holidays not found because it's not among our enum values that we have here. So that was a pretty a bit complex way of using enums with extensions. And let me tell you, like, you always get to use generics with extensions on enums and everything. So here we're just combining that. We had our enums and we wrote some extensions which we're combining with the generics and making the enums on the extension to be only based on enums, right? So this exists only for all enum wherever we define enums, and the first where or null, you can read more about that. The first element satisfying the test or null if there are none. So it's pretty straightforward what it does. And yeah, I think this couple of examples, you can try them again on your own. You can try maybe of cars and the other ones to be able to get whatever you can achieve with it. You can try the enums on your own. So we're going to close this and we are now going to go for example 3. Permit me if I can spell. Okay, example 3. Now in this example 3, we're going to be using generics with classes, right? We've seen with functions, we've seen how they work with functions, we've seen how we could use generics in an extension, right, coupled with enums. So now we're going to go for a class, and for this case we're going to do a transformer, right, a class transformer which takes a value of a certain data type to another data type, right? So it's going to be pretty clear when we see the visual of it. So, and I think we've already done classes, right? So we start with a keyword class and say let's just call it transformer, if I can spell transformer. Okay, and as well, we know that whenever I want to start with generics, we always have this less than and greater than sign that we use, right? Now in this case, we're going to be dealing with not just only one data type, because remember I said we're going to be able to change from one data type to another. That means we're going to require two generic, let me call them variables or holders, from which that is going to be able to understand that this we're requiring, or we're going to be dealing with two different data types. So let me just put it here and maybe you understand better. So we're going to deal with something like T and R, or maybe T and U. I think it's usually T and U or T and R, anyone. So we're going to deal with T and U. Now the T here represents a variable of a specific data type, that's one, and the U represents the variable of another data type, right? If we wanted to change, for example, from int to string or from string to int, then int here in our case, from int to string, int here in our case is going to be T, and string here in our case is going to be U. So we now open the class. Okay, we have the final U function, can we call it function, that takes in T, and it has the name of transform, if I can spell. Okay, and we bring in our, should we require this? Okay, just transformer. Okay, so yeah, basically we haven't done anything complex, just a final, just initializing some variables. Okay, we have a function U that takes in type T, right, transform, which is just what I was explaining. So a function which is just going to be able to take in a certain data type and then produce another data type, another output of a data type. Yeah. And then we are now going to define that function here, U, and we're just going to say apply T input, and we're going to return transform at input. Right, so this is like the basic skeleton structure. Now we are the ones who are going to be defining how we want to be able to do that. So let's go ahead, main, and in the main we're just going to have a transformer. Okay, let's start with saying going from int to string. Okay, and we're going to call, the name is going to be int to string. and we are going to use our transformer. Okay, transformer, we're going to apply the function that we want here, int I, which is going to return to us number on this $i. Okay, the value of the local variable into strings in use. Okay, so basically what I've just done here is that this into string, I've just specified the data type, which is what you can see here. It's a transformer that takes an integer and returns to us a string. That's why we're using t and u. Okay, and then we call now the transformer, and we pass to read a transformer function, right, which is this function here, which takes in an integer I. Okay, an integer I, and then we pass to read, and then it returns to us the number, just returns to us a number, and then like the number that we pass to it. So in that case, now we're going to print int into string, and we call the function apply. Now the input that we're going to pass here could be any number of our choice, right? Since in our transformer class we have already defined the function to be able to parse, like to be able to go from an integer, okay, integer to string. So it's already defined how we can be able to pass from an integer to a string. Then we just call the apply function, and the apply function here is going to take in our input of type t, which is this 5 here, and then call the transform function, which we earlier passed to our transformer class constructor. Okay, so we can call our terminal and say dart example3. Nope, not example3. Dart example3. Okay, and we get number 5. Okay, so that's that. Okay, that we can pass in any other number. We could as well as like to pass in maybe 10. Okay, and if we call example 3, and I think we can do something like try to get the runtime type. Let's say to get a runtime type, what we get, and we obviously see that it's a string, so it's actually returning to us a string, as we can see here. Even if we wanted to create a variable here and say int, well, let's just say I always like to give my variables kind of like weird names, like hello. Let me say int, let's just say string value. I can do this. Let me say string value, and if I was to int to string dot apply, maybe let's say 10, and close that, and you can see from here that our return type is of type string, right? Source type string already. Even the runtime type confirms that we're dealing with a string. So let's say now we can be able to go maybe from string to integer, or why not maybe from a string to a list of ints. Yeah, I think that would be actually be cool, to a list of ints. Okay, so as usual, I'm just gonna copy this rapidly. So we are going from a string to a list of int. So going from a string, and we're going to say string to list. I'm just gonna string to list. Now this comes the hardest part, where we should be able to determine what our function is actually going to be like, right? A transformer. So what we're going to do here, we're going to use something in that called code units, right? Now code unit, it's more of like ASCII, right? It returns to us some ASCII values of each character, right? So it creates a list in which, in that list, each character represents or is being assigned a value, right? And it adds to that. So let's just go ahead and do that. So I'm going to say here string of type s. Okay, and we're then going to have s dot code units. Yeah, so as you can see here, code units is a list of ints, so it gets each of these values from the string and somehow adds them to the list, with each value being a numerical representation in the ASCII format, something like that, I guess, if I'm not mistaken. So yeah, an unmodifiable list of UTF-16 code units, so you can find out what UTF-16 means if you want to explore more into that. So the next part, now we're going to print, let's call the print, and our string to list, and let's say something like Dart. Let's see what Dart gives us. Come on, we're learning that, so we should be dealing with Dart. Oh, forgot to call the apply function. Apply and keyword Dart, and the value that we're sending to it is Dart. Okay, so we see here we call the string here a class. Okay, we'll initialize the class with whatever value we need. Let me remove this, apply separator, and yeah, I think that would do, though it's still on my code completer. It's trying to be smart. Okay, so string to list, and then we apply, and then we do that. So let's clear, and then let's try that out. Okay, so as we can see, we have the values from the UTF-16 format, where we have Dart, D, A, R, and T. Okay, so you can go ahead and explore. You can try from string to int, or whatever changing type, or whatever transformer you have in mind. But always remember, whenever you instantiate a class and you like provide the values to it, you should always call the apply function to it. And yeah, I think that will be that. Now we'll go to I think that should be the last example, interfaces. Now here we're going to see how we can apply interfaces with generics. Now for this example, it's going to be a little bit complex, and you will have to require you to wrap your head around maybe some couple of times, but I'm going to try my best to explain it as simple as possible. So let's go example 4. Example 4.dart. Okay, we can close this example 3, and okay, now in this example 4.dart interfaces, yeah, we're going to be dealing with some interfaces or abstract classes, or interfaces and abstract, anyhow you want to go with them. So here we're just going to be able to create a simple caching functionality, right, to be able to cache, and from there, whatever we cache, it's just going to be able to return to us that value. But we're going to make the cache generic, such that we can be able to store in it any value of, or any variable of any data type, right? So let's begin then. So we're going to start with an abstract class. Abstract class. Well, from your knowledge, right, I hope you know abstract classes can't be instantiated, but they can be implemented. And I think you can't extend abstract classes. Let me see. Class hello, extends cache. Can we do this? Okay, you can extend, but you can instantiate them. Okay, so we have that, and we are going to provide a function that returns t. That's one, is to be able to get, right, to be able to get whatever we pass to it. So we're going to call that key, which whatever class is going to be implementing this class can be able to provide its function, because remember with abstract classes we just define what the function looks like. Well, we just define the function, but in the class which is going to be implementing it, it's going to define the internal structure of maybe how that particular function works actually, right? So we're going to call the next part. We're going to work on the next part. Now we have the get, right? Now we should be able to set as well. We should be able to set. So if we want to be able to set, then we should be able to have a string key, okay, and a value t, right? Whatever this t value is, because remember, if we are creating some sort of caching, then we should be able to get our values based on the string we earlier provided for it to be able to store, right? So let's continue, and then now we're going to create a class, call it memory cache, okay, that implements, nope, not importing Flutter dart, that implements our cache, okay, that implements our cache. Type t isn't a type, blah 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 blah, so it can't be used as a type argument. Okay, so the error is because this class, since it's implementing this type t, I also need to define a type t here of type t. Okay, so and from there I think I can, missing concrete implementations, I can override those classes and provide now their implementation, or how they are going to behave whenever we call this memory cache. So we're going to have a final map, and remind you that since we have a, let me call it key value pair, obviously the best option would be to use a map, right? I think that they call it map in other languages. I don't think it's still map. Yeah, a map, not a set but a map, right? Yeah, so we're going to say it's of type string. I think my code completer is trying to be smart. That's always actually smart by helping me go along. And yeah, so I'm making this value private by making sure that nothing outside of it can be able to access this cache, because we don't want like anybody else being able to access the cache outside of the class and modify it. All modifications will be happening by the functions. That's, if we could see it as a getter and a setter, right? Whereby these functions here are the ones who are modifying the cache. We can directly go and modify it. Okay, so to provide the implementation for this, we're just going to return the cache and the key, right? The key that we provided to it, and this should not be null, right? Because we can only call get. Let me see, what was this error saying? A value type t optional method can be returned. Let's see if we can say if it is null, then we can return null. Okay, because this states not null, so let's try to see this here. Okay, maybe we can, value of type object can be returned from get because it has a return type of t. Or can we just say not found? Okay, so we can say here something like because we have to return type t. Well, let's just leave it for now. This is something we can expatiate on later on, or you can try doing that. For example, if what if the value that we're looking for isn't found in our cache, then we should be able to return that value as it is, right? Yeah, but just that in this case we are assuming actually that the value is present, right? That the value, we have stored the value in the cache and it's actually present. But you can go on your own and try to implement what if the value wasn't present, right? Using either you return null or you return a string, it doesn't exist, okay? And yeah, so we could just do that by easily changing the type of this get here, right? Easily changing that and just returning maybe a string, right? Making a string nullable and so on and so forth. So but that's it. Now to be able to store in the cache, okay, we're just going to say cache, right, and we're going to give it the key and the value, right? Simple as that, and void, and then we can return. So now we are going to define our main, and in that main we're just going to call can I bring this down, cache, okay, and it's going to be of type string. So we're going to start by first of all caching a string. So let's say string cache, and this string cache we're going to call memory cache. Now the reason why we're calling cache here, not actually memory cache, is because this memory cache implements the cache. So its return type, even without doing this, if I did this, let me say final, and if I do this, for example, you're going to see as memory cache of type dynamic, or we could still do this string, okay, and you say it's memory cache of type dynamic. But since I want the return type to be of this cache, since it's implementing the cache, right, I can as well use cache string to be my return type here, right? So that's why it's not complaining of any error. I will have here the cache of type string. So in this case now we are not going to be able to say string cache, and we're going to set a value. Let's say, for example, what can we go with? Let's say greeting, and here we're just going to say hello there. And since we have set it, I think we should be able to print that value and say cached value. Can I get rid of this? We should be able to say cached value, okay, and $sign, and then we're going to call a string cache dot get, and the key is going to be greetings. Now I just found out that I spelled greetings here wrongly, so greetings, and if we try to get this, then we should be able to see that in our console. So let's go with this, and let's print that out, do that, and okay, so let's try to say this here, example 4, and then we get a cache value, which of course was hello dot, right? And well, since we didn't implement the case scenario whereby what if we didn't have the value, what is going to get returned to us, an exception is being shown, right? So null checker, well, this is just to say that it doesn't exist here, but we're actually returning it. So this a little exercise you can play around to try to implement that. Like, what if the value doesn't exist in our cache, then we should actually return null, right? So we should be able to do that, but yeah. So let's see, back to greetings, and since the string cache returns a type of string, we can be able to, can we get to the runtime type and see what the runtime type is? So we see that our value is actually a string. So what is gets returned to us here is a string. So if we replicate this and do for an integer and say int cache, okay, int cache and int cache, and here we're trying to set an int. Okay, already you can see here we have this that analyzer that's saying the argument type string can be assigned to int, simply because we define in a function that if we are setting, then this t here should be the same as this t here, right? But you see that here it's an integer, and here we're trying to pass in a string. So if we say, for example, 9, and we set that in the cache, and then we try to get that value, Then we get int, which of course is this 9 that we're getting back from here. So let me just say num value. Okay, num value, because actually by doing this I'm going and overriding the greetings value that's already there in the cache. So if we do this again, yeah, so we get now string and int, and if we remove this runtime type here, then we can be able to see that we get a string, okay, hello dart, and a number which is just 9. So guys, that was just all about generics, and you can try to go with more complex examples on your own, try them out. I mean, generics are really super cool in terms of code flexibility and code reusability. It's gonna really help you a lot. So writing faster code and yeah, reusable, right? So that was that with 4 simple but like elevating the complexity from simple to complex examples using generics. So you should try wrapping your head again around and try some couple of examples to be able to like get used to that. So thanks for watching.